Group Assignment 2. Communication Principles, SEEE3533 for group members. Muhammad Halmi bin Abdul Razak, Abdrahim bin Abuzaki, Che Muhammad Hasnan bin Che Hussein, and Faris Umadi bin Abdul Ghani. Our group are working on Mission 3. Our topic covers pulse modulation multiplexing. Pulse modulation. What is pulse modulation? Pulse modulation is a form of modulation where the carrier signal is a pulse train. The parameters of these pulses are amplitude, width, position and code, which were varied in accordance with the information signal. This technique is widely used in digital communication systems and plays a crucial role in transmitting data efficiently and accurately. The importance of pulse modulation. Pulse modulation is essential in modern communication systems due to its ability to transmit information over long distances with minimal distortion and interference. It is used in various applications, from telecommunications to control systems and digital signal processing. Types of pulse modulation. Pulse amplitude modulation (PM), pulse width modulation (PWM), pulse position modulation (PPM), pulse code modulation (PCM). Firstly, pulse amplitude modulation (PM). Definition: in PM, the amplitude of each pulse in the pulse train is proportional to the instantaneous value of the analog signal. Application: used in Ethernet communication and in some types of data conversion. Advantages: simple implementation and high bandwidth efficiency. Disadvantages: susceptible to noise and signal degradation. Second is pulse width modulation (PWM). Definition: in PWM, the width duration of each pulse is varied according to the amplitude of the analog signal. Application: widely used in power delivery systems, motor control, and LED dimming. Advantages: high power efficiency and robustness to noise. Disadvantages: requires complex circuitry for generation and demodulation. Next we have pulse position modulation (PPM). Definition: in PPM, the position of each pulse within a time slot is varied according to the analog signal's amplitude. Application: used in optical communication systems and some wireless communication systems. Advantages: good noise immunity and efficiency in bandwidth usage. Disadvantages: requires precise timing and synchronization. Last but not least, pulse code modulation (PCM). Definition: PCM converts the analog signal into a series of coded pulses, representing the signal in digital form. Application: widely used in digital telephony, audio recording, and CD or DVD storage. Advantages: high fidelity and robustness to noise. Disadvantages: requires significant bandwidth and complex encoding, decoding processes. Applications of pulse modulation in control systems, used in controlling the speed and position of motors and other actuators. In digital audio and video, PCM is the standard method for digital audio and video recording and playback. In power electronics, PWM is used for efficient power delivery and motor control in various industrial and consumer applications. In optical communications, PPM is employed in fiber optic and free space systems. Advantages of pulse modulation. 1. Efficiency. Pulse modulation techniques, especially PWM, offer high power efficiency, making them ideal for power-sensitive applications. 2. Noise immunity. Digital nature of pulse modulation provides robustness against noise and signal degradation. 3. Scalability. Pulse modulation techniques can be easily scaled for different applications and bandwidth requirements. Moving on to multiplexing. What is multiplexing? Multiplexing is a technique used in telecommunications to combine multiple signals into one medium or channel for transmission. It maximizes the use of available bandwidth and improves the efficiency of data transfer. Importance of multiplexing. Multiplexing is crucial because it allows for efficient utilization of resources and reduces costs. This technology covers many aspects of telecommunications and data networks. Types of multiplexing. 1. Frequency division multiplexing (FDM). 2. Time division multiplexing (TDM). 3. Wavelength division multiplexing (WDM). 4. Code division multiplexing (CDM). Firstly, frequency division multiplexing (FDM). Definition: in FDM, the total bandwidth available in a communication medium is divided into non-overlapping frequency bands, each carrying a separate signal. Advantages: simple to implement and can transmit multiple signals simultaneously. Disadvantages: requires a large amount of bandwidth and is prone to interference between adjacent frequency bands. Second is time division multiplexing TDM. Definition: in TDM, multiple signals share the same channel but are transmitted in different time slots. Advantages: efficient use of bandwidth and easy to implement for digital signals. Disadvantages: requires precise timing and synchronization, and is less efficient for bursty traffic. Next we have wavelength division multiplexing WDM. Definition: a type of FDM used specifically in optical fiber communication, where different data streams are transmitted using different wavelengths colors of light. Advantages: high data rates and efficient use of fiber optic cables. Disadvantages: requires expensive optical components and precise wavelength control. Last but not least, code division multiplexing CDM. Definition: in CDM, multiple signals are transmitted simultaneously over the same frequency band, but each signal is encoded with a unique code. Advantages: high resistance to interference and multipath fading, and efficient use of bandwidth. Disadvantages: requires complex signal processing and synchronization. Next we have applications of multiplexing. Telecommunications. Multiplexing is used to combine multiple phone calls or data streams over a single communication link. Optical fiber communication. WDM is used to significantly increase the data capacity of fiber optic cables. Satellite communication. TDM and FDM are used to transmit multiple signals to and from satellites efficiently. And now for the advantages of multiplexing. Resource efficiency allows multiple signals to share the same medium, maximizing the use of available bandwidth. Cost effectiveness reduces the need for multiple physical channels, leading to cost savings in infrastructure. Improved performance enhances the performance and capacity of communication systems by allowing simultaneous transmission of multiple signals. Before we end this video, please support us by scanning the QR code for survey purposes. Thank you to Dr. Marwan for this great opportunity. We appreciated it. Your good deeds would not go unnoticed.